Okay, ready to dive into a topic that's, well, quite literally all around us. Water.
I'm all for it. It's amazing how essential it is, yet we often take it for granted, right?
Exactly. I mean, think about it, it's everywhere. Oceans, rivers, lakes, even those fluffy clouds up in the sky. But how much do we really know about what makes water, well, water?
It's true. There's so much more to it than meets the eye, and that's what we're here to uncover. To go beyond just seeing water and really dive deep into understanding it.
I love that. A deep dive. I'm already intrigued. So where do we even begin with something as vast as water?
Well, I think a good place to start is with something we all learned about in school, but maybe haven't thought about too much since the water cycle.
Oh yeah, the water cycle. I remember those diagrams with arrows and clouds and rain. But if I'm being honest, it always seemed a bit, I don't know, abstract.
I get it. It can seem that way, kind of like a science textbook concept. But it's actually this incredible dynamic process that's happening all around us all the time.
Okay, you've piqued my curiosity. Let's break it down. How does the water cycle actually work?
All right, picture this. Imagine a tiny water molecule hanging out in the ocean, just soaking up the sun.
Sounds like a pretty sweet life, but I'm guessing it doesn't stay there forever.
Nope. As the sun warms the water, our little molecule gets energized like it's had a shot of espresso, and it evaporates into the atmosphere, turns into water vapor, an invisible gas.
So it's like our water molecule is hitching a ride on a sunbeam. Up, up, and away.
Exactly. It rises higher and higher, but as it goes up, it starts to cool down, and all those tiny water molecules start clumping back together. They condense.
Condensation. Isn't that how those fluffy clouds form, like a giant water vapor party up in the sky?
You got it. It's a cloud formation party. But like any good party, it eventually has to wind down. As more and more water molecules join the fun, the cloud gets heavier and heavier.
Oh, I can see where this is going. It's like a water balloon that's about to burst.
Exactly. And eventually it does. All those water molecules fall back to Earth as precipitation. Rain, snow, sleet, hail, you name it.
Wow. So our little water molecule traveler has come full circle, back to where it started. Or, wait, is that the end of the journey?
Not quite. That's the beauty of the water cycle. It's a continuous loop. The water might land in a river and flow back to the ocean. Or it might seep into the ground and become groundwater. Or
Hmm.
maybe it'll be soaked up by a thirsty plant.
So it's like a never-ending adventure for our water molecule. It could be
Yeah.
anywhere, doing anything. I'm starting to see why this cycle is so important. But before we move on, can we nail down a definition for the water cycle itself, just to make sure we're all on the same page?
Absolutely. The water cycle is the continuous movement of water on, above, and below the surface of the Earth. It's driven by energy from the sun and the force of gravity. It's like a giant planet-sized water slide.
Love that analogy.
Yeah.
But I have a question. We always hear about saving water, right?
Yeah.
Conserving it, using it wisely. But if it's constantly cycling, why do we even need to worry about it?
That's a great question. And it gets to the heart of why understanding the water cycle is so important. While water is constantly cycling, the problem is that the vast majority of it is salt water, the kind that fills up our oceans. And we can't drink that.
Right. Salt water is a no-go for us humans, so even though our planet looks blue from space, all that water isn't exactly useful.
Exactly. Only a tiny, tiny fraction of Earth's water is the kind we can actually use fresh water.
Okay, now that's starting to make sense. It's like being surrounded by a giant supermarket, but only having access to one small aisle.
Perfect analogy. And that's why it's so important to be mindful of how we use that precious fresh water, because it's limited. It's not an endless supply.
Totally makes sense. Now, I've always been curious about this. What actually makes ocean water salty? Is it like all the tears of heartbroken mermaids?
Haha, I'm afraid not, though that's a pretty poetic image. The real culprit is dissolved minerals, mainly sodium chloride, which is basically table salt.
Ah, so it's like the ocean is a giant bowl of soup that's been seasoned by rocks over millions of years.
That's a great way to put it. Rain erodes rocks, carries those minerals into rivers, and eventually they all end up in the ocean.
Okay, so that's why we can't drink seawater. It would be like chugging a salt shaker. But how much salt are we talking about? Like, could you sprinkle some ocean water on your fries?
Haha, not quite. The average salinity, that's the term for saltiness of ocean water, is about 35 parts per thousand. So for every kilogram of seawater, there's about 35 grams of salt.
Still sounds pretty salty to me, and I've heard about places like the Dead Sea, right? That's got to be super salty.
Yeah, the Dead Sea is an extreme example. It's about 10 times saltier than the average ocean. That's why you can practically float on its surface.
Wow. So we've got fresh water and salt water, two very different beasts. But before we move on, can we just clarify What exactly is salinity? Just so we're all on the same page.
Good point. Salinity is simply a measure of the amount of dissolved salts in a body of water. It's what determines whether water is considered fresh or salty, and it has a huge impact on marine life and, of course, whether or not we can use that water for drinking or growing crops.
Got it. It's amazing how much complexity is packed into something that seems so simple at first glance.
Right.
Okay, so we've covered the water cycle, the difference between fresh water and salt water, and salinity. I'm feeling pretty enlightened already. But now I'm curious, where does all that fresh water actually hide?
It really is like a hidden treasure, isn't it? This fresh water we all depend on. We've talked about the oceans, but that's mostly salt water, like we said.
Right, not exactly the thirst-quenching kind. So spill the beans, where's all that precious fresh water hiding?
Picture this. You're flying over the North Pole, maybe bundled up in a parka or something. What do you see?
Probably lots of ice and snow, maybe a polar bear or two.
Exactly. And you know what? A huge chunk of Earth's fresh water is locked away in those frozen landscapes, glaciers, and ice caps.
Wait, so those giant ice cubes are basically giant freshwater reserves?
Exactly. They hold something like 68% of the world's fresh water.
It's incredible, right? Frozen in time, like a snapshot of Earth's history.
That's wild. But there's a catch, right? It's not exactly easy to access.
You got it. It's like having $1 million, but it's frozen solid. Not very useful for everyday spending.
Makes sense. So that's one place. Where else can we find fresh water?
Well, let's go underground. Have you ever thought about what's beneath the surface of the Earth?
To be honest, I usually just picture dirt and worms. Maybe the occasional buried treasure chest.
Well, there's definitely dirt and worms down there, but also something much more valuable, groundwater. It's water that's stored underground, within layers of soil and rock, kind of like underground lakes and rivers called aquifers.
So it's like a whole secret world beneath our feet.
Exactly. And this hidden source makes up about 30% of the world's fresh water. Wow, that's a lot of water we don't even see. It's amazing to think that our drinking water could come from, well, underground. So we've got ice and underground water. What about the fresh water we can actually see, like in rivers and lakes?
Ah, yes. Those are the freshwater sources we're probably most familiar with, and they're super important for both ecosystems and for us humans. Rivers are like the veins of our planet, constantly flowing, carrying fresh water across continents.
Rivers are so mesmerizing, aren't they? The way they just keep moving, carving their way through the landscape.
And they provide water for drinking, for irrigation, for transportation. It's incredible how much we rely on them.
Then there are lakes, those beautiful still bodies of water, perfect for a relaxing swim on a hot day.
Or a paddleboard adventure, and they act like giant bowls, collecting rainwater and snowmelt. Plus, they provide home to tons of fish and other aquatic life.
So just to recap, fresh water is found in glaciers and ice caps, underground aquifers, rivers, and lakes. That covers a lot of ground, literally. But before we move on, can we just define each of those freshwater sources, just to make sure everyone's following along?
Sure. Let's start with glaciers. A glacier is a large, persistent body of ice that forms on land when snow accumulates and compacts over many years. It's essentially a slow-moving river of ice.
Got it. What about groundwater?
Groundwater is fresh water that exists beneath the Earth's surface, in the spaces between soil particles and rock fractures. It's stored in underground reservoirs called aquifers.
Okay, makes sense. What about rivers? How would you define a river?
A river is a natural flowing watercourse, usually fresh water, that's flowing towards a larger body of water, like an ocean, sea, or lake, sometimes even another river.
And finally, lakes. What makes a lake a lake?
A lake is a body of relatively still water, localized in a basin surrounded by land. It's fed and drained by rivers and other outlets.
Okay, great. So many different forms of water. It's mind-boggling. But I have another question. What about the water that falls from the sky? Rain, snow, all that good stuff. Does that count as a freshwater source?
Absolutely. Precipitation is a major part of the water cycle, and it's constantly replenishing those freshwater sources we just talked about.
So every time it rains or snows, it's like a giant freshwater delivery service.
You got it. It's a vital link in the water cycle, bringing fresh water back to Earth's surface. It fills up those rivers and lakes, seeps into the ground to replenish groundwater.
That makes sense. I've always loved the feeling of rain, that fresh, clean scent. It's like nature's way of hitting the reset button. Now, before we move on, do you have any questions about those different freshwater sources? Anything that's still bugging you?
Well, we talked about how most of the world's fresh water is locked away in glaciers, right? But those are like way up north or down south. Does that mean we can't really use that water?
That's a great question. What happens to all that glacial water? And how does it become accessible to us?
That's the big question, isn't it? It's not like we can just, pop up to a glacier with a giant straw and start sipping.
Yeah, I'm not sure a glacier smoothie would be very refreshing. So how does that water actually make its way to us?
Well, remember that amazing water cycle we were talking about earlier? It plays a key role here, too. As temperatures rise, glaciers naturally melt a little bit at a time.
Oh, so like a slow drip.
Exactly. And that meltwater flows into rivers and streams, eventually making its way to lakes and oceans. It's a vital source of fresh water for lots of regions, especially during those hot, dry months.
So it's like nature's built-in irrigation system. Keeps things flowing.
Hmm.
But I have to ask, what about climate change? We hear all the time about glaciers melting faster because of rising temperatures. Is that a problem for our freshwater supply?
That's a really important point. And yeah, it's definitely a concern. As global temperatures rise, glaciers are melting at a much faster rate than they used to.
So that steady drip is turning into more of a gush.
Exactly. And that can lead to problems, flooding in some areas, water shortages in others. It's all connected, you know? Climate change, freshwater availability, the health of our ecosystems. It's a complex web.
It really drives home how important it is to protect these freshwater sources, doesn't it? From those massive glaciers to those underground aquifers we talked about, and of course our rivers and lakes.
Absolutely. Every drop matters. And how we treat water, how much we use, even the choices we make in our daily lives, it all has an impact. It's all part of that interconnected web we were talking about.
Well, I think we've covered a lot of ground today, pun intended. We've journeyed through the water cycle, explored those hidden freshwater treasures, and even touched on some of the challenges we face when it comes to water. Feeling pretty water-wise over here.
Me too. It's amazing what you can learn when you take a deep dive into something, right?
Speaking of deep dives, I think it's time for our favorite part, the Q&A. I'm ready to test your water knowledge. Are you up for the challenge?
Bring it on! I'm always happy to talk about water.
Okay, first up, let's go back to basics. Can you give us a final, concise definition of the water cycle? You know, that incredible journey water takes around our planet.
The water cycle is the continuous movement of water on, above, and below the surface of the Earth, driven by the sun's energy and the force of gravity. It involves processes like evaporation, condensation, precipitation, runoff, and infiltration. And it's a closed system, meaning that the same water has been cycling for billions of years.
Wow, that's pretty mind-blowing. The water we drink today could have been part of a prehistoric ocean or a raindrop at the time of the dinosaurs.
It's true. It really puts things into perspective.
Okay, next question, salinity. Why is the ocean so salty? And why can't we just drink it when we're thirsty?
Salinity is just a fancy word for how much salt is dissolved in water. And ocean water is salty because of minerals that have been accumulating for millions of years. Mainly sodium chloride, which is the same stuff as table salt. And we can't drink seawater because that high salt concentration would actually dehydrate us. Our bodies would need more fresh water to flush out all that extra salt.
Right. Got to stick to freshwater sources for our hydration. Okay, last but not least, let's talk about those precious freshwater sources. We've got glaciers, groundwater, rivers, and lakes. Can you give us a quick rundown of what makes each one unique? A final definition for each, if you will.
You got it. Let's see. Glaciers are those massive, slow-moving rivers of ice that form on land when the snow accumulates and compacts over many years. Think of them as frozen reservoirs of fresh water. Then we have groundwater, that's fresh water that's found beneath the Earth's surface, stored in those underground reservoirs called aquifers. Rivers are natural flowing water courses, usually fresh water, making their way to a larger body of water, like a highway system for fresh water. And finally, lakes are those beautiful, relatively still bodies of water localized in a basin surrounded by land. They're like oases in the landscape.
I'm telling you, my brain is overflowing with water knowledge right now. But in a good way. It's just amazing to think about all these different forms of water and how they're all interconnected.
It really highlights the importance of understanding and respecting water, doesn't it? From those massive ice sheets to the tiniest raindrop, it's all connected. And it all plays a role in keeping our planet healthy and thriving.
So the next time we turn on the tap or take a sip of water, let's take a moment to appreciate where it came from and the incredible journey it took to get to us.
Well said. It's a reminder that we're all part of this intricate water web, and our choices matter. By understanding and respecting water, we can help ensure that it's around for generations to come.
On that note, we've reached the end of our deep dive into the world of water. Thanks for joining us, and we hope you learned something new about this essential element that we often take for granted. Until next time.